Okay, here we have my latest purchase, my newest rolling mill, the Durston Agile C70. So today first of all, we're gonna unbox this, first impressions out of the box. Then I'm hoping to bolt it to my office desk. I'll need to figure out what bolts I need, drill some holes, we'll bolt it down. Once I've got it bolted down, and then melt some gold and some silver and test it out. We'll turn gold and silver ingots hopefully into some wire and some sheet. Now this is actually my 6th rolling mill. I've got 3 Durston ones, bigger ones, full size ones, and 2 vintage ones. I've got the Durston one on like a pedestal stand with 2 manual rolling mills on, so one side has got a wire rolling mill with reduction gearing from memory, and the other side is sheet without reduction gearing. I've had that. That is one of the first ones of that model. I got that when that model first came out, so 15 years old, maybe more, maybe 20 years old, somewhere in that region. I've got a Durston rolling mill more recently, similar, even the biggest ones they do, or close to it, a round one with a stand, which I still haven't got the hang of, I still haven't figured that out. And then more recently I bought 2 vintage ones, which this is going to replace, because working with the idiosyncrasies of vintage tools just adds a whole new layer of complexity to what we do. I thought they looked cool, they do look cool, but just one attempt at using them, so anyway, we can. The key point of that is not. I'm not just trying to just show off that I've got 6 rolling mills. I am just showing off that I've got 6 rolling mills. I'm very proud of my rolling mill collection. But the key point of that is we'll be able to compare how this baby Durston rolling mill works in comparison to the full size, top of the range manual rolling mills they make. Now, what I would first of all say is my older Durston rolling mills, in my opinion, are better than the newer ones. They're just better constructed. They seem to have become enamoured with plastic parts, which was frustrating because on my older Durston ones, on the wire ones, there's this pointer, which on my original ones is made of metal, and it works. It works. The new one, it's made of plastic. It's too light, and the end's too thick, and it slips out when you're using the roller. It doesn't actually. It's not fit for purpose, and it means you end up trying, especially when you're going to the really small holes. It actually means you end up putting the wire through the wrong holes because it's in the wrong place. It would be better off not having it. But it's that is one of the features that made Durston rolling mills. It's a really simple thing, but it made their mills stand out as some of the best in the world. That feature, I don't believe Pepe Tools have it. Some of the Italians definitely did. I'm not sure if they still. I'm not sure if they even still make them, but yeah, Durston were the best rolling mills in the world. But if they continue adding plastic parts that should be metal, they're just going to end up, comparable to Pepe and comparable to the Italians, which are still better than the cheaper, inexpensive, Indian-made and Chinese-made ones. But yeah, if they carry on adding plastic parts, they're not going to be the best in the world anymore. Yeah, it's such a simple. The frustrating thing about that is that it's such a simple thing to make in metal. It's very inexpensive as well. I'm going to have to make it myself. It's such a simple thing. I can make it myself. I might make a nice little brass one or copper coloured one. I think. Pimp my rolling mill. But yeah, I've got to make a part for it because the one supplied, and it's an expensive tool, Anyway, rant over. I'll show you. I will show you what I mean. Anyway, let's unbox this and take a look at my new rolling mill. Obviously, despite my frustration with plastic parts, I'm obviously still a fan of Durston tools. They do make great tools, and they make them in metal. Also, I got a phenomenal deal on this Black Friday deal. Once in a lifetime opportunity, too good to pass up. And I bought these vintage rolling mills recently, which I was going to bolt to my office desk. I'm hoping this will work, whereas the vintage ones, a few idiosyncrasies that need to be ironed out. So I'm hoping this will work straight out of the box. So the Durston Agile C70 rolling mills was a great deal. This compact rolling mill may be the perfect fit for our needs, especially when compared to the larger Durston mills in our main workshop. As we unbox the Agile C70, our aim is to discover if it's the right fit for our smaller studio setting. Durston is known for quality, but how does this smaller model stack up? We're here to find out. Durston described the C70 as designed with a direct drive and combination rolls. It's compact yet offers a range of features like 9 wire rolling grooves and a maximum sheet thickness of 3.5mm, but does it have the versatility we need in this smaller footprint? Durston mentions durability and precision even with their smaller models. With a cast iron body and hardened rolls, the C70 promises longevity, but will it meet the high standards set by its larger counterparts? As we integrate the Agile C70 into our workflow, we'll be testing it rigorously. It's important for us to assess its performance thoroughly before passing any judgment or making recommendations. And we're excited to see how this smaller mill performs. Can it handle the task we throw at it with the same proficiency as the larger Durston models? Only time and testing will tell. So stay tuned to see if this compact model holds its own in a professional setting. Okay, our Durston Agile C70. First impressions, how cute. They're like a toy, a well-made toy. They are well-made. 10 kilos, I think the box said they weigh. They're a well-made mill. My concern with these is they're small. They're one of Durston's smallest rolling mills. It's not I like them, they look cool, but I don't think they're going to be any use for what I really want to do with them, which is reduce ingots. I can't make an ingot that small. So I'm going to have to, I think all these would really be suitable for is reducing pre-made, pre-bought wire. If you're buying wire from a bullion dealer or sheet, the sheet size of this says it opens to a maximum of 3.5mm. It doesn't, because I just tried to put some wire through it to see what size it was. I've got 3mm, this is 3mm diameter wire, and that won't go through the sheet size, so the sheet size is less than 3mm. I think our ingots are 6 or 7mm, but you use a way larger wire gauge, wire groove than that one. We'll test it out. I won't know until I test it out, but I don't think it's going to do the early stages of our ingots unless we significantly peen them for hours to reduce the size. If that sheet side opened up, maybe I can take the top off and get it to open up more. If that opened up a lot more, you could do the ingots, you could rotate them 90 degrees, but it'd have to open up double what it is now. I don't think that's going to happen. No more than double. It's opening up less than 3mm. You would really need that to be open up sort of 7, 8mm, and then you could put the ingots through. Whether you'd be able to turn the handle or not is another thing. But I think what we'll have to do to use this is I'll have to use the vintage rolling mills, which open up a lot more than this. Similar size to this, but they open up a lot more. I have to use the vintage rolling mills first to significantly reduce the size of the ingots, peen them, reduce the size of them, and then go on to this. But then, why don't I just go the whole way on the vintage rolling mills? Which I bought these to replace. We'll test them out. I mean, they are exactly what they said they are. They don't quite open as much as they claimed, but it's not Durston's doing. I was just hoping they would. I was hoping they'd be bigger than. I wasn't hoping the mill. I knew how small the mill was. I was just kind of hoping that maybe we could get away with it says 7mm wire, and that I believe them, that probably is the 7mm wide hole, but I know for a fact on our other roller mills, we start off with a 7mm wide ingot and it goes in a much larger hole than the one on that. So we'll find out.
So today marks a significant step in enhancing our jewellery making capabilities. We're setting up the Durston Agile C70 rolling mill, a tool that promises to revolutionise the way we work with metals, so let's get started. First things first, we need to prepare our workspace. We're using our trusty Milwaukee Tools cordless drill equipped with a 10mm flat spade drill bit to create the perfect foundation for our new equipment. Safety and precision are key. We carefully mark the 4 points on our desk where the rolling mill will be anchored. These points are strategically chosen to ensure there's enough clearance for the rolling mill's handle to turn smoothly. And here we go. The drill bit makes quick work of the desk, creating clean and precise holes. The 10mm flat spade bit is ideal for this task, offering just the right size and depth for our needs. With our holes ready, it's time to secure the Durston Agile C70 rolling mill. We're using robust M8 nuts and bolts for a firm and stable installation. This step is crucial to ensure our rolling mill operates safely and efficiently. Aligning the rolling mill with the drilled holes takes a little bit of finesse. We make sure it's perfectly positioned at the edge of the desk, allowing full movement of the handle, an essential feature for seamless operation. And now the final step, we've bolted down the rolling mill, tightening each nut securely. This not only ensures stability but also prolongs the life of our rolling mill by reducing vibration during use. And there you have it, the Durston Agile C70 mill is now part of our studio. This setup promises a new level of precision and efficiency in our jewellery creations. We can't wait to start using it, test it out and share our experience with you. With our rolling mill now secured to our bench, we now need to make an ingot of gold and test out the wire capabilities of the mill. So, in the world of jewellery making, every gram of gold holds a story of beauty, artistry and responsible sourcing. Today we're embarking on a journey with 10 grams of 9-carat gold, a treasure not just for its value, but for the ethical path it's travelled to reach us. With precision and primarily convenience due to its flat bottom, we use a porcelain Chinese soup spoon, an unconventional choice that reminds us that creativity knows no bounds. Convenience meets tradition as we measure out the perfect amount of gold grain, ensuring accuracy with our trusted jeweller's scales. 10 grams of gold ready to embark on a transformation, each grain a promise of possibility, glimmers with potential as we prepare for the alchemy of creation. As the grains tumble into the crucible, we're reminded of the age-old craft of melting and moulding, a process that turns raw elements into objects of beauty and desire. This is where artistry meets craftsmanship, where the heat of the flame will forge new beginnings. So, as we turn these responsibly sourced whispers of the earth into a testament of beauty and sustainability, the journey from grain to glory is just beginning. In the meticulous world of goldsmithing, every detail counts, especially when working with precious metals. Today we're transforming 10 grams of gold into an ingot, a process that combines ancient alchemy with modern techniques. Our journey begins with the smith's little torch, a tool as precise as it is powerful. The melting tip, specifically designed for tasks like this, becomes our alchemist's wand, ready to turn solid gold into molten brilliance. Preparation is key. We gently preheat our graphite ingot mould with a reducing flame, a delicate dance that deposits a layer of carbon soot. An ancient trick, a secret passed down through generations of goldsmiths, ensures our gold ingot won't stick and will release smoothly. With the ingot mould warmed and waiting, we turn our attention back to the crucible. A sprinkle of borax, flux, and the oxygen levels rise thanks to our trusty oxygen generator, transforming the flame into an oxidising flame. Under its relentless embrace, the gold succumbs, transitioning from solid to liquid, a pool of potential waiting to be shaped. And now the moment of truth. With a steady hand and a confident heart, we pour the molten metal. The liquid gold flows, a river of light, finding its new home in the ingot mould. This is a dance of precision and trust, a testament to the goldsmith's art. In the forge's glow, we're reminded that the art is not without its dangers. Health and safety are paramount, each step taken with respect for the fire we wield. This is a task for the skilled, a journey not taken lightly. As the gold cools, solidifying in its new form, we're reminded of the transformative power of heat, metal and human ingenuity. From raw grain to a gleaming ingot, we've witnessed a metamorphosis, a small but profound creation that speaks to the heart of goldsmithing. In the delicate dance of metallurgy, we've turned raw gold into a tangible testament of craftsmanship. A 10-gram gold ingot, each gram a story of transformation and possibility. As our ingot takes its first breath, solidifying under the watchful eye of the flame, we tread a fine line between tradition and innovation. We transition the flame from oxidising to reducing as the ingot solidifies in the ingot mould, ensuring purity and perfection. In the world of goldsmithing, opinions diverge like rivers from a single source. To quench or not to quench the ingot after pouring, that is the question that divides many. Some believe in the sudden embrace of water to temper the metal, while others advocate for the patience of air to gently coax the ingot into its final form. We choose a path less trodden, a harmony of contrast, allowing the ingot to air cool first, embracing the slow descent into solidity, a testament to the metal's resilience and our respect for its journey, and the ingot, now cooled, is prepared for annealing, the flame rekindled with purpose, because secondly, we use the wisdom in tradition and the annealing process that promises renewal. The ingot, reborn in the heat, is then quenched in water, a swift, decisive act that seals its strength and ductility, readying it for the next steps. In this cycle of heat and calm, of fire and water, we find the essence of metallurgy. Each ingot, a canvas of gold, awaits the touch of the maker to unleash its full potential to be shaped into objects that capture and adorn. As we stand at the crossroads of old and new, we honour the gold ingot not just as a product, but as a promise of beauty yet to be wrought, of stories yet to be told. So join us as we journey from ingot to artistry, where gold meets imagination. In the meticulous craft of goldsmithing, every stroke, every detail contributes to the integrity and beauty of the final piece. Today we're delving into a step often overlooked in the transformation of gold ingots into sheet or wire. Peening. The art of delivering a series of precise small hammer blows is a practice not commonly mentioned in textbooks or online tutorials. Many even suggest that this step is optional, but we stand by it as a necessity. The process is more than just a tradition, it's a safeguard against the future. By carefully working the surface of the ingot, we introduce a controlled stress that helps prevent cracking and splitting as we later roll or draw the gold into sheet or wire. Peening is not merely a step in the process, it's a dialogue between the artist and the metal. It requires understanding, patience and a deep respect for the material's properties. This stage is crucial in preparing the ingot for its transformation, ensuring it can withstand the pressures of shaping without faltering. In a world eager for quick results, peening stands as a testament to the virtues of thoroughness and diligence. It's a reminder that in craftsmanship, as in life, taking the time to lay a solid foundation is essential for enduring beauty and strength. We champion this vital yet underappreciated step in goldsmithing. The trade needs more exploration and explaining of the nuances of peening, for it's in these details that true artistry is born. So now we've made a gold ingot to test out on this tiny rolling mill. The limitations of this, one of the smallest rolling mills Durston make, the size capabilities are becoming a little clearer. Our ingots come out somewhere between 7 and 8 mil square, well, rectangular, and once we've peened them, we get them down somewhere between 6 and 7 mil. Now, according to Durston's website, this baby rolling mill does up to 3.5 mil sheet. Ours doesn't. You couldn't even get 3 mil sheet through that. So it's somewhere between 2.5 and 3 mil sheet that will take. And it says it's got wire grooves from 7 mil to 1 mil, which would lead you to believe that it could do 7 mil wire. It can't, nowhere near. The largest I think you can get through that will be 5 mil round or 5 mil square, somewhere between 4 and 5 mil. We're going to find out because I've got larger Durston rolling mills. So what I'm going to do is I'm going to take our gold ingot, which is about 6 millimeters square at the moment, and then I'm going to put that through the wire grooves on our larger Durston mill, and I'm presuming that those grooves are just the smaller one. They're the same dimensions as the smaller ones on our other mills. So I'm going to take this down to the wire groove above the one on this mini mill, and then we'll find out what size wire that starts at. So what this is going to be useful for is finishing or reducing the size of pre-made sheet and pre-formed wire. As far as forming ingots, not much use unless you can make ingots smaller than 4 or 5 mil, which is quite challenging
to do actually. So let me reduce this down and then we'll see what size wire that can do.
So we're going to use our larger Durston DRM W130 to reduce the size of our ingot from its current size down to below 5mm. Why the ingot needs to be below 5mm for a rolling mill that claims to have a 7mm wire groove, we'll explain later.
Okay, I've used our larger Durston rolling mills to reduce the size of our ingot. This started out between 7 and 8mm, peened it. I've then used the mills to take this down. Now I did check the maximum size we could fit through our tiny Durston rolling mills on the way, and the maximum square wire we can fit through is a fraction over 5mm. The same for round wire, a little bit over 5mm diameter. Now it does say it's got a 7mm wire groove, and in theory it has. The maximum opening of the square wire groove from top to bottom is about 7mm, but unless you're putting a piece of flat sheet through or paper, you cannot get 7mm wire through it. The largest piece of square wire you'll get through is about 5mm square, and the largest piece of round wire is about 5mm diameter. So I've actually taken this down to a little bit under 4mm, and the way I put our wire through rolling mills is I mark one end with a needle file, and then I will put it through the same direction of travel each time. And having a mark on the end means even if I drop it out one side and it's hard to tell which end I put through before, I've got the mark on it, so I know I can put it through in the same direction each time, but each time I'll rotate it 90 degrees. And that gets us a nice even stretch. Now some jewelers will put it through in different directions. They'll put it backwards and forwards. When I've tried that, it increases the likelihood of cracking. Someone advised me to put it through in the same direction of travel each time, and that appears to help reduce in cracking and get us nice, perfect lengths of straight wire. So that's the way I'm doing it and sticking to it for now, but that might change if I find another better way. So now we've got this down to a little bit under 4mm. We can test out our new tiny rolling mill for the first time. Put it through its paces with some 4mm square wire.
So today marks a new chapter in our crafting journey as we introduce the Durston Agile C70 rolling mill to our studio, a tool that promises precision and versatility. So it's time to put it to the test with our 9-carat square wire. Our mission, to meticulously reduce this almost 4mm square wire down to a sleek around 1.6mm. It's a process that demands patience and precision, qualities that this rolling mill is designed to deliver. So as we embark on this task, our rolling mill becomes the centrepiece of transformation, each pass through the rollers a step closer to our goal. For this journey, we've captured around 12 minutes of continuous footage, showcasing the raw and real experience of working with this remarkable tool for the first time. While the art of annealing is crucial in maintaining the wire's workability, we've chosen to streamline your viewing. The initial annealing is shown to set the stage, but subsequent processes are replaced with a bloom transition, maintaining the focus on the rolling mill's performance. For those who share our passion for the details, this unedited glimpse into the craft is for you. Witness the Durston Agile C70 in action. It's the very first trial by fire in our studio. We understand, however, that 12 minutes of wire rolling can be quite monotonous for some, so if you're eager to see the final result and explore more of what this rolling mill can do, feel free to skip forward to around 12 minutes into the future and join us on this inaugural run of the Durston Agile C70. It's more than just a rolling mill, it's about embracing new tools, new challenges and the endless pursuit of craftsmanship. Okay, we've used our Durston Agile C70 to reduce the size of some square wire, and on the one hand it's done a phenomenal job. However, I do have an issue with the size capabilities and Durston's description. Now, you could, and they probably would, argue that the sizing they've used is correct. However, somewhat misleading. You can, and I will explain where they've got the sizes from. Justifying using them, not so much, but we'll come to that later. What we need to do is test out the sheet capabilities. Now, all we're really going to use this little mill for, it's only got 40 mil of sheet. Now, in our home office, home studio, all we're going to do is roll out probably solder, hard solder. I do roll out hard solder because it comes quite thick. It's quite hard to cut into small pieces. When you roll it out, we half the thickness of it. It makes it easier to cut, and also because it's half the thickness, you're automatically cutting smaller pieces. But it's also easier to cut smaller pieces, if that makes sense. But testing it out with solders, it's not a great test, is it? So the kind of thing I think people would buy this for is reducing offcuts, maybe sheet that they've stamped out less than 40 mil wide. Now this is probably 50 mil wide. Yeah, 50 mil wide. So too wide to go through the mill in its entirety. This is 1 mil. We've stamped guitar picks, plectrums from this. Now, there's still some usable pieces on this. However, they would be more usable if they were 0.8 or even 0.6 mil thick, and they'll obviously be larger. So what I think I'll do, I'll cut some of the pieces off of this, and as a test, what I'll do is we'll attempt to reduce small pieces of this from 1 mil to 0.8. I'm not going to anneal it first of all. This is straight from the bullion dealer. So we'll reduce it to 0.8. Once we get it to 0.8, if we get it to 0.8, I'll then anneal it, and we'll then attempt to go from 0.8 to 0.6. I think that's a pretty good test for the sheet section of our C70 mill. And then we'll come to our final verdict. So the flat section of our rolling mills are only 40 millimeters wide, so we're going to saw a piece off of this offcut around 35 mil wide at its widest point. That will give us some scope for the piece not going through completely straight, and the potential for it to widen during rolling, although they do tend to extend in the direction of travel, so I would expect it to get longer than it does wider. So, welcome to a pivotal moment in our journey with the Durston Agile C70 rolling mill. We're embarking on the task of rolling out flat sheet for the very first time using this tiny rolling mill. Our starting material is a sheet of silver, less than the 40mm width the roller accommodates, yet its irregular shape presents a unique challenge. As we pass it through the rollers, the uneven dimensions may lead to a non-uniform thickness across the sheet. Our goal is to reduce the thickness initially from 1mm to approximately 0.8. As the rollers embrace the silver, we will witness the transformation and hopefully coming remarkably close to our target measurement. To ensure the silver remains workable, we will need to anneal the sheet. This process relaxes the metal, making it malleable once again, ready for further refinement. Once the silver's annealed, our aim is to achieve a final thickness of approximately 0.6mm. The Agile C70 is performing admirably, yet the irregular shape of our sheet means that the thickness is varying slightly in places. In our commitment to transparency, we've chosen not to edit this section for those eager to see the final verdict. However, feel free to use the playback controls to skip ahead and see our full review of the Durston Agile C70. This journey with the Agile C70 from irregular beginnings to a near perfect finish underscores the importance of starting materials and technique in achieving consistent results. So stay tuned for our final thoughts on this versatile rolling mill.
So, the Durston Agile C70 rolling mill. Our verdict, the review, after unboxing it, mounting it to our desk, we then made some gold wire, an ingot, reduced it using our larger rolling mills so that it would then fit in the Durston Agile C70. Then reduced that from just under 4 to around 1.6, and then we used it to reduce a small piece of sheet from 1 mil to about 0.8 and then down to 0.6. Now, is it any good? Is the rolling mill any good? It's a good value for money. Would we recommend it? It's done a good job at what it's done. It produced some beautifully finished wire, and it did a pretty good job, as I would say, as good a job as the larger mills, albeit quite difficult without reduction gearing to reduce sheet. I wouldn't want to put really thick sheet through it. The spec says it will do 3.5. Ours doesn't even open to 3, so no chance. And I really wouldn't want to. We'd have to get someone else to hold down the desk while I crank the handle. But it'll do 1, I'm sure, 1.5. But you do it, but it's going to take some doing, and you'd have to really anneal it and do it in small increments. Would I recommend it? To be honest, to be brutally honest, if I'd paid full price for that, I'd put it back in the box and send it back, not as described. That's the reality. We got a phenomenal deal on it, so I'm keeping it, but full price. The way they've sized it, and this I think, I'm going to give them the benefit of the doubt and just say it's human error. Their sizes on Durston's website are all over the place. Inconsistent, to say the least, the way they have sized the different mills. So what they've, and I figured out what they've done. With this, they say the wire grooves are 7 to 1 mil. With our larger Durston 130 mil 19 groove, they say it's 8 to 1 mil. It's twice the size. So something's wrong, but also that the same rollers from that 130, they're the same rollers in the D2 and the same grooves in the D4, and they're apparently 10 mil. So there's a mistake somewhere, or multiple mistakes. What they've done is, on this one, the 7 mil refers to the distance across corners, because that's the configuration of the square holes. It's the distance between corners fully opened, 7 mil. The problem with that is the distance between corners is 1.4 times larger than the distance across, than the width of the wire that would be fitting in that hole. So, which is the way all jewellers measure their wire. In fact, I think it's the way everyone measures their wire, obviously apart from rolling mill manufacturers that want to sell more rolling mills and overstate the capacity of the hull. Now you might be thinking, well, okay, 7 mil square wire, it will 7 mil across centres, which is equates to 5 mil wide, fully open, but it will do 7 mil round. No, it won't do 7 mil round because you're thinking outside the box. You need to think inside the box for this. It's the same. So it will only do fully open. It's still 7 mil across the corners of the square, so it will only do 5 mil diameter wire. So, yeah, okay, 7 to 1. But that means it will only take 5 to 0.7. Like divide 1 by 1.4. I think it's 5 mil to 0.7 mil wire. But then on the larger mills, on quite a few of the mini mills, they use that 7 to 1 description. But then on the larger mills we've got, they say 8, which I think is that measurement, is the width. So that would be the width fully closed of the largest hole. But then on another description it says 10 mil, which again is the width of wire, which I think is correct, 10 mil, fully closed. So it will actually do larger. See, it's just inconsistent. It's quite hard to compare them. I've got no idea what measurement the other manufacturers are using, because I mean you can buy a similar spec rolling mill on eBay for £140. Spec, not build quality. What I would say about them is they're phenomenally well made, over engineered. But yeah, I'm guessing the cheap Chinese and Indian ones are using that across corners measurement. I looked at Pepe tools. I think they're using the width of wire. Otherwise, I mean, they're probably selling so many that they'd have had an issue with doing it any other way, I think, by now. So, which again, like that 6mm measurement is quite small. Recommendations. One, I would definitely recommend buying a Durston rolling mill. I've got 4 of them. But, like, my concern is in recommending one of these small ones, or any of the small ones, is that someone watching this considering a career in jewellery making, or even a side hustle, or a hobby that becomes profitable, a side hustle, and ultimately a career, is looking for a rolling mill, thinking, well, Durston are the best. Can I get away with a smaller one rather than a larger one? Because the larger ones are a lot of money. No, you can't. Not if you're considering a career, because I think ultimately you're going to have to make wire, not necessarily sheet, but wire, because you can buy most usable thicknesses in most alloys of sheet, probably larger than you're ever going to be able to make yourself and better quality than yourself. Wire you cannot. You cannot buy all of the alloys in really the sizes and profiles you need. You're definitely going to need to start with a draw bench and draw plates, and the next step is making ingots and rolling them out. And I'm going to go off on a little bit of a tangent here, but back when I've started out selling jewellery tools, and we always wondered why we sold so many doming blocks and doming punches, but you never saw not a lot of domed jewellery. And you can use doming blocks for other things, sorting out rings and settings, but there were we saw these really expensive, cool looking doming blocks and doming punches, all the Italian stuff looked really cool, polished steel and wooden blocks, and we'd sell loads of this stuff, but you never saw the results of it. And it was the same with mini mills. We'd sell loads of mini mills, but none of the upstream or downstream products. Like, we'd sell dozens of these things, but very little in the way, relatively speaking, for melting or wire making. So it was, but I think what it boiled down to is that I go around all my friends' house, they've got a Roberts radio in the kitchen, they never listen to the radio, they've got dual 8-slice toasters, and they can't eat bread. And we've all got fancy coffee machines, you go in everyone's garage, they've got useless gardening tools they never use, kitchens, everyone's full of kitchen appliances. But I think everyone involved in any craft, like all carpenters, will have unjustifiably expensive tools, and I'm probably more guilty than anyone else. I've got loads of expensive jeweler's tools that I just wanted them, I thought they looked cool, I've got plans to use them, but I never have. And what happens so that's what was happening. People were buying these, they just thought they looked cool and they wanted them. That was it. And they were buying mini mills because they thought, I'm a jeweler, I need a rolling mill. Durston are the best, I'll get a Durston mini mill. They never used them, but there was a huge demand for them. And there was no set, they never got rid of them. They never upgraded because they'd never used the one they had. So they just sort of sat, they were an ornament, cool looking ornament. But like, we couldn't see it because we were surrounded by this stuff all day, but we couldn't understand it. But then, if you're surrounded by cool looking coffee machines all day, you can't understand why someone would see them as desirable, but they just did. And I think what ultimately happens is, because there's huge demand for these tiny rolling mills, the consumer demand dictates the design of them to some extent. So you end up with you effectively end up with useless. That's why you end up with, I'm not saying that these are useless, but that's how you end up with useless multi-tools. Because why would you buy just a spanner when you can have a spanner that's also a screwdriver, and a screwdriver that's also a spanner? Instead of having one good spanner and one good screwdriver, you've got a useless, cheap amalgamation of the two, which is useless. But it just gets thrown, just gets thrown at all, it's never used. You get I hope you get the gist of what I'm saying. Is I think a lot of these things, people look at it and they go, do I need sheet? And what I'll get, like, this one's got both, and it does, this one does 5mm, this one goes up, says it does 7mm. Yeah, the bigger the better. And like, you end up with these tiny rolling mills that won't really do a lot, but they look like they do everything. Most people buy them, never use them. So there's a very limited use case for rolling mills this small. What I would recommend is, one, you buy a Durston rolling mill. I don't see in the long term, if you're planning a career in jewelry making that you're probably gonna have to make your own wire. There's one rolling mill that if I had to get one rolling mill, I can't see any viable alternative, and that is one of the large wire mills. 130 mil wide, 19 grooves, whether it's 8 mil or 10 mil close, I'm not sure. I've got one, I could measure it, but it featured earlier in the video. But yeah, I don't think anyone else makes a wire rolling mill, a manual one, that goes that big. So you've got three options. You've actually got four options technically. We've got the 130 mil dedicated wire mill on a pedestal stand that came as a set with 130 mil wide sheet with reduction gearing rolling mill. But you can buy those rolling mills independently of the stand. They're about £1,000. Or you can buy the stacks. There's a 130 mil stack which has the 19 wire grooves, 2,500. Or there's the 150 mil, which currently is about 3,000, and then you've got the combo we've got is currently about 3,000. It's a lot of money, but I don't see any viable alternative if you want to make your own wire, certainly from ingots. All the smaller ones are going to be useful for I don't really know what they are useful for, because if you're buying wire from a bullion dealer and adapting the shape of it, which is how we started out, and I would recommend you do that before you make ingots. Master the art of using a draw plate and draw benches. You can actually buy, say you want 2 by 1 mil D, you can actually buy quite close, so 2.3 by 1.5 D shape. You can't get 2 by 1, or if you want a 30% ratio. So you can buy quite close in most of the alloys, and then you've just got to adapt it. So I don't see why you'd need a square, I don't see why you'd need a rolling mill with square holes, unless you had to buy 3 mil round, because it is much quicker to reduce the size of wire in a rolling mill than it is using draw plates. But you can, for most things, you can buy round or D quite close to what you need. So I don't see why you'd need a wire rolling mill if you weren't making ingots. Other than if we go back to you just want one because you think they look cool. I do see, however, a use for flat, however limited. For flat, you can roll out solder. We use them for rolling out hard solder, also for pattern plates. So, but then the mini mills and the combination mills, unless they're at least 70 or 80 mil wide flat, they're no use, because that's how wide most of the pattern plates are. I think ours are 2.5 inches that we got ours back in the day from India. I haven't bought any for a while, but they're not going to go through a mini mill. So we're going to get quite a lot of use out of the Agile C70 as a addition to our larger roller mills, because I can do the heavy lifting as such in terms of reduction on our larger roller mills, and then here in our studio I can do minor adjustments, roll out solder, maybe some bezels, maybe make some bezels, that sort of thing. So it's an expensive addition, but it's a useful addition. So would I recommend it? You've got to really want a Durston rolling mill and really want a small one to buy a C70, but I would extend that to buying any mini rolling mill. I think they'd be much more useful if you had entirely wire mini mills and entirely sheet mini mills. If that was 70 mil, I think you can actually get one 70 mil, but without the reduction gearing, it's going to be really hard to put through a pattern plate. So it goes, but you've just got to buy a big one. They're thousands. I know that's not what everyone wants to hear, but yeah, I think for most people, you don't need a rolling mill. There'll be some disagreements with that, but most people don't. First of all, you need a draw bench, draw plates for wire, and then once you've got the hang of that, then you need to start making ingots, and then you're going to need to reduce them. For that, I don't see any alternative other than them, because, and the reason I say that is because it's actually really, you can get 4, 5 and 6 mil ingot moulds. They're really hard to get good ingots from, really hard. I've tried. Our ones come out, the smallest graphite ingot moulds we've got right now, 5 mil wide, but they come out thicker. Although they're 5 mil wide, they always come out a little bit lumpy, sort of. They might be 5 mil wide, but they're sort of 6 or 7 mil high. It's hard to get that. It's hard to get good ingots 5 or 6 mil unless you've got induction melting tip up gear. But the chances are, if you're watching a video about mini mills, you haven't. Neither have we. But then you can get really good quality ones. So yeah, it's a fantastically well-made rolling mill. Like I said earlier, it's over-engineered. If I paid full price for it, I think at the moment they're 570 plus VAT. I'd send it back and buy the £1,000 wire one. If I'd paid that for it, we paid 280 plus VAT. So for a studio mill, that's great. What I would have done, in fact, I would have sent it back, got the £1,000-odd wire mill, and then also purchased a sheet, £150 sheet one off eBay to test out. Probably broken it. I'm quite tempted actually to get one of those £150 ones to test out for pattern plates, because it always worries me a bit putting the pattern plates through the Durston ones. I'm just worried about damaging them, because I reckon back in the day, before Durston were making pattern plates, if I said I was putting a steel plate through their rolling mills, they'd have told me I was doing it all wrong. Don't do that. But now they sell pattern plates, it's cool. However, what I think is going to be the case, the Durston rolling mills are phenomenally well made. They're rock hard. The gearboxes are great. I think they've even got one now that's like 50-1. I want to test out the Indian one. In my mind, I'm thinking I'm going to get a cheap Indian one to wreck with the pattern plates, but I think I genuinely will wreck it, because they're not going to be as well made. They're just not. And the gearing's not going to be as good. So, yeah, I think I actually, as scary as it is putting a steel plate through my very expensive Durston sheet rolling mills, I actually think they're probably better suited than buying a cheap one to do it with. We'll find out, because I think, yeah, it does worry me putting steel plate through a £1,500 rolling mill. It just does. But then it's probably, like I say, it's probably better suited than a £200 rolling mill to do it. It's probably more capable as well. Maybe in an ideal world, I'd have one that was very precise for precious metals, so that it was completely even, and then another one to stick steel plate pattern plates through. But then, it's a lot of money. So anyway, I'm waffling now. It is a phenomenally well made rolling mill, but it's a lot of money for what it is. And my concern is, if you're buying it as a cool tool, as an ornament, and you're not going to be melting, making your own ingots, you have no intention of doing that, you just want to roll out solder, yeah. If in the future you think you're going to be making jewellery as a career, I think that you're going to have to bite the bullet and spend £1,000 on a wire rolling mill and £1,000 on a sheet one, or get the combo if you're limited by space. And when I bought my current Durston rolling mills are currently 3,000 plus tax. The tax alone is more than that mini rolling mill. However, I didn't pay that for them. They're at least a decade. They're probably 15, maybe 20 years old. I bought them ex-display. They'd been to some shows. I think they went to Switzerland. They went to the they travelled England. They were in a shop window for a while, but they were never used. They looked second-hand, had a few show freight stickers on them and whatever, but they'd never been used. So I reckon, I can't remember because it was a long time ago, but I reckon at the time I paid about, I reckon they were about 2,000 quid at the time. But the D2s were about 1,500 quid. I think they gave them to me for this, they wanted rid of them, and they gave them to me for the same price as whatever the price of a D2 was at the time, which was about 1,500. So I could probably sell them now, because I've looked after them, they're in great condition. I could probably sell them now and get my money back. So and I think every jewellery tutor will probably give you the same advice. One, get a Durston one, get the biggest one you can get your hands on, because they don't generally go down in price, and yeah, the longer you delay it, the more you'll be paying. And sometimes, like this one, good deals do come up. Sometimes you'll find second-hand ones, but there can be issues and idiosyncrasies with damaged second-hand tools. So my advice, get the biggest Durston ones, either the 130 wire, 130 with 130 sheet, or a D2 or a D4. If you're broke as a joke, just starting out like we all were, you may have to make do with one of the cheap Indian ones to start with. But what I definitely wouldn't do is to save money, buy a smaller mill. I personally would reduce build quality, and what I mean by that is, rather than buy a Durston one, buy an Indian one. Pepe Tools won't like me saying this, but instead of buying a Durston one, buy a Pepe Tools one. They are less expensive. They're probably the middle ground between a Durston and a cheaper Chinese or Indian one. I quite like the look of the wire one as well, but I've got a round wire one and it really doesn't work. But I like the look of the Pepe Tools with court profiles on it. That looks great. Probably won't work. And that's the other thing, D profiles as well. The D profile, like the D, I think if you're going to buy a big one, I can't see much advantage of the 150, the D4 over the D2, unless you really need that additional width in sheet. I don't think you could put a pattern plate through it width-wise quite. But I think I don't have much luck with I use them every time as well. Every time I'm making D-shaped wire, I use the extension molders on ours. The profile, there's something up with the profile on, it's not right. I think it's too shallow. I might be wrong though, it might be too deep. I think the profile is like probably 30% rather than like 50 or 60. So it kind of just rounds off square wire, it doesn't radius it. But then I don't know how you fit, you'd have to make one for me 50% or 60%, and we'll see if that properly radiuses it ready for a draw plate. All it really does is provide a visual aid for which way I'm putting it through the draw plate. I've never successfully made D-shaped wire, but I think people do. But then maybe they're just not a perfectionist like me. What's one of your, that's the job interview question, isn't it? Now I'm waffling. Right. It's a phenomenally well made rolling mill. It's overpriced. Don't buy the £500 one. Buy the £1,000 Durston one for wire, or the £3,000 one that we've got. Hope that was helpful. Toodles.